Assalamu alaikum banat, how are you? So for today it's just gonna be a quick video on lesson 1.1 solving linear equation. We won't go through the lesson details, keywords and all ideas. We'll be only solving some direct questions and some word problem or different ideas. So let's see. I'll just go directly into the first idea I want to talk about is basically how can I solve linear equations. Okay, so we're used to having linear equation from last year. We're used to have it something similar to this: a variable associated with a coefficient that is either a division have a division relationship or maybe a multiplication relationship, and then next to the variable there is an addition or subtraction of a number. This format, we were used to work on it in grade 7 last year, but this year we got introduced to a new way of writing, a different way of having as well linear equations, which is this one. Maybe the variable is added to a number, but the whole term, all of it together, is divided by this number as well. So you're gonna also see a lot of other different formats, but for now let's stop here and start solving these. Okay, so for the first one, we know that we need to simplify or to solve this equation. Our main goal is to isolate the variable x, and in order to do that we need to look for the term or we need to look for the number or the term that is far away from x, or the operation of it is to be done last whenever I want to solve that equation. Substitute in that equation. So looking at this, the closest operation to x is the division, so therefore I'm gonna leave it and work on the addition of 2 in order to solve it. So I have to cancel the addition of 2, which is the term that is far away from x. So in order to do that, I need to use inverse operation. The inverse of addition is subtraction of 2. And because it's equality, whatever you have to do on one side, you have to do on the other side, okay? Now the 2 is cancelled. I have x over 3 left equals 8 minus 2 is 6. Now from here I can proceed by on isolating the x by cancelling the 3. To cancel the division of 3, the inverse operation here that I will use is multiplying by 3 on both sides. Now the 3 is cancelled. X alone equals to 6 times 3, which is 18. Of course, you can check your answer by substituting the x with 18 and check out if it's gonna end up being altogether 8. Okay, we're done with this equation. Now let's see if this other way of writing the linear equation gonna have any difference on the answer, and what are the steps that should be performed first. So in the first one, we had to cancel the 2 first because it was the operation that was far away from x. Now coming into this one, apparently the 2 is super close to x. It's basically next to x. It's the first operation that you have to do to x, and then you have to divide by 3. Therefore, the priorities goes to cancelling 3. So in order to cancel the division by 3, again, why did I want to cancel division by 3 first? Because it's the it's the last operation to be done, or it's an operation that is done for the whole term. But the 2, it's operation that is done only for the x. So I have to wait a bit, cancel whatever outside, and then go inside and cancel the other terms, okay? So let's see. So in order to cancel the division of 3, I have to multiply by 3 on both sides. Don't forget to spell your equality. The 3 is cancelled, and I have this part free of the division of 3. I can work on it now. Equals 8 times 3 is 24, Now, going from here, I have to cancel the addition of 2 using subtraction of 2 on both sides. Now the 2 is cancelled, x equals 22, and as you can see, it's a huge difference. Again, if you substitute by the equation, I'm going to substitute with you. So if you want to check your answer, you have to substitute your answer in the equation. So substitute by x. So my equation was x plus 2, all of it over 3 equals 8. How can I check? Instead of x, I'm gonna substitute that with my number, with my value that I got, 22. 22 plus 2 is, 24 over 3. 24 divided by 3 is actually 8. Then my answer is correct. Okay. طيب. Now, let's see other examples. The type of examples we actually want you to practice on. These were just ideas, like basic ideas. Okay. So let's start by this one. Now again, first of all, split your equality into 2 parts. And then here, this is my variable x. You have to look for the operation that is far away from x, or the number that is far away from x. So apparently 2 is the closest and 15 is the farthest. So in order to cancel 15, ask yourself, what's the sign of 15? The sign of 15 is addition. Although we have subtraction here, but this negative is the sign of 2, not 15. So in order to cancel the 15, you have to use the opposite of the sign of 15. So same as before, because the previous example, the 2 was positive, we had to subtract by 2. Same here, because the 15 is positive, we have to subtract by 15. Don't get confused by the sign after it. We don't care. We only look at the sign before the term, only. We always do that. This is not something new. 15 is cancelled. Now rewrite your problem. Please, girls, please write your problem step by step. Don't go and skip steps and do it in your head, please. Sometimes small mistakes happen because you don't rewrite your answer properly. Can you see this? I want to see that in every single step. Now, next, what should I do? I have, of course, the negative 2 that is stick to the bracket. This negative 2 is multiplied with the bracket. But Miss, there's a negative. Yes, I don't care. It's only the sign of the number. But actually, this number, what's the relationship between this number and the bracket? Because they are stick to each other, then there is a multiplication. Okay? So in order to cancel multiplication, we only divide by the negative number 2. It happens to be negative, but it holds no meaning to subtraction. It just happens to be negative. Divide by negative 2. Now the 2 is cancelled. So here I have, you can just write it without a bracket, by the way. I have 3 minus 2x equals 31 divided by 2. Half of 31 is 15.5. But because one of them is negative, using smiley faces. This is negative, this is positive, of course. Whenever you are dividing or multiplying by different signs, the answer should be negative. Okay? Now from here, look, we have the 2 is associated with x and the 3 is far away from x. Again, ask yourself, what's the sign of 3? 3 is positive. I don't care about this sign that is here. This sign is a negative for the 2. The positive is for the 3. Okay? Now to cancel the 3 that is positive, we have to subtract by 3 on both sides. 3 is cancelled. Now what do I have left? I have negative 2x here equals. From here, just line up decimal points, 0. And then because they are same signs, I can add them. 5, put the decimal point. 5 plus 3 is 8 and 1. So it's 18.5 negative because we take the sign of the greater number. Now from here, ask yourself lastly, what should I do? Of course, I need to cancel the negative 2. But again, as you can see, negative 2 is multiplied to x. Okay? please don't get confused by the sign of it. If it was in the middle between the 2 and x, then yes, it's an addition or subtraction relationship. Okay? But since it's a negative number, stick to the x, then this number, it's a negative number, is multiplied with x. And to cancel it, you have to divide by this number that is negative. Okay? Now the 2 is cancelled. I have x equals, if you divide these two, you're gonna end up with 9.25. But since both of them are negative, the answer will be positive. And this is your answer. Of course, if you take it back to the problem and substitute with this, you're gonna, of course, get a correct answer. Now let's try to do this equation. Here, very similar idea to what we did. Again, separate your equation and then think which number is far away from x. Is it the 2? Is it the 1? Is it the 4? Of course not the 3. It's the 4 because it's the last operation that will be done with x. Okay? So the sign of 4 is positive. To cancel this positive sign, to cancel this positive term, you have to subtract or have a negative opposite of it on both sides. The 4 is cancelled. Now what do I have left? I have left on the left side, I have 3x minus 1 over the 2 equals 9 minus 4 is 5. Now moving forward, what should I cancel next? I have negative 1 next to the x, but I have the 2 that is for the whole term, which means that it's the last operation to be done. So I have to cancel the division here. It's a division relationship by 2, cancelled by multiplying by 2 on both sides. The 2 now is cancelled. What do I have left? I have 3x minus 1 equals 5 times 2 is 10. Next is to cancel what? Of course, the negative 1 using positive 1. Halas, the negative 1 is cancelled. What do I have left? Sorry. I have 3x equals 11. 10 plus 1 is 11. Then here the 3 is multiplied with x, cancelled by dividing by 3 on both sides. So x equals, you can leave it as an improper fraction. You can find it as a decimal. I think it's going to be 3.3333. It's a repeating decimal. Or rewrite it as a mixed number. So 11, there is 3 3's inside it. So 3 whole number will go outside. And then how much left? We have 2 left out of 3. Now I think it's going to be 3.66666. It's a repeating decimal. Anyways, you can either leave it like this, or find it as a decimal, which is 3.6 repeating. Okay? All works. Now let's take another example. Here we have a word problem. This word problem is actually very easy, simple, but it's very super nice. Let's see. So here we have the problem says that please use CUBE's strategy whenever you are reading a word problem. Circle out the variables and you know the whole steps. Okay? Now, the parameter of a geometric figure is the sum of the length of its side. Okay? So, they're saying here that the parameter of this pentagon, 5-sided figure on the right is 27. Write an equation for parameter, solve the equation, and then find the length of each side. Okay, so they gave me a very nice information. They said that the parameter of this shape is equal to 27. Now I know that this thing is what? It's the sum of all length. So basically this length plus this length plus this length plus this length plus this one. If I add them all up, it's gonna be equal to 27. Let's add them up. So the first one is 3x plus x plus x plus x. So I added this plus this plus this plus this, and then plus 3x. All of them equal to 27 because these are the sum of all length of its sides. Okay, now let's work out our problem from here. Since I have a variable, this means that of course I need to solve it. If I was able to find x, this means that I found this side, which is already x, okay? And I can find this side afterwards. Type, let's see. So I have, this is another idea in this lesson. What if I have a linear equation, but as you can see, I have the variable x written multiple times. Previously, in our examples, we used to see the variable x written only one time in the equation, one time only. But here, it's mentioned out multiple times. Now, what can I do in order to have it as we know, as usual? What can I do? How can I simplify that? What should I do? Before you solve your equation and you follow the steps to isolate the variable, you should have already one variable. Otherwise, you won't be able to isolate the variable. You're gonna get confused which variable I should isolate. So since all of them have x, then they are like terms. This means that I can combine them. I can say 3x plus x is 4x. X plus x is 2x. And 2x plus 3x is 5x. 5x plus 4x is 9x. I can go ahead and combine them, each two together. If you want to combine them mentally, you want to list them on top, like write them vertically and combine them, whatever suits you, just find the answer. For me, myself, what I always like to do is, I like to add these numbers, the coefficients of x. Here it's 1. So I'll say that 3 plus 1, 4, plus 1, 5, plus 1, 6, plus 3, it's 9, and we only write the variable only one time, because this is how combining a variable works. You only add the coefficients, and then write the variable down. Equals to 27. Now, 27. Now I can go ahead and solve my equation since I have only one variable. خلاص, 9 is multiplied with x, just divide by 9 on both sides. X equals 3. Now I know that for the sides, this side is 3 centimeter, this side is 3 centimeter, and this one is 3 centimeter. But what about this one? It's 3x. So 3 times the x is 3, which is 3 times 3 is 9 centimeter. This one is the same, which is 9 centimeter. If you want to check, just double check. You're gonna check that it is 9 plus 9 plus 3, 3, 3. Is it gonna give you 27? Is it right for the parameter? It's gonna end up being 27. Let's see. 9 and 9 is 18. 3 plus 3 plus 3 is 9. 18 plus 9 is actually 27. Then my answer is correct. Okay. Type. I'll be solving with you one last example for having also multiple variables, but this one, I mean variables mentioned multiple times, but this one is having a small idea. Okay, let's see. So here they're saying that the sum of 3 consecutive integers is 132. What are the 3 integers? So let's get to know what is consecutive integers. What does this keyword mean? Consecutive integers are basically integers in their counting orders. So for example, 4, 5, 6, 7, 8, 9, all of them are consecutive integers. 1, 2, 3, 4, 5, 6 as well. But what about this one? 1, 3, 4, 7, let's say 11, 100. Nope, they should be like back to back. So the number after next to 1 should be supposed to be 2. So as you can see, consecutive integers between each number and the first one, there should be each number and the one next to it, there should be one more like plus 1, only one more. Okay, now let's see, going back to the problem. They said that the sum of 3 consecutive integers is 132. Do I know these consecutive integers? No. Since I don't know them, then I can say that, let's say that the first one is x. I can call it x, a variable, because I know in math any term, in any problem, anything that is unknown, I usually tend to place it or write it as a variable. So in this case, these integers, I don't know what they are, but they're basically some numbers. I'll call the first number x. Suppose that the first number is 2. Okay, the second number should be what? It should be 3, right? But if I want to use x, how can I write it as x? So I can say that it's the same as x, but the difference is only add 1. Okay, because again, if the first number is 2, the second number is 3. What happened? I only add 1. Same here. If I call it if I want to call it as a variable, because it's not 2, I'm just putting an example. If I want to call it as a variable for the first one, the second one I will use the same variable, just add 1. But what about the third one? It should be 4, right? If I want to use x, it's what? It's x, the original one, which is 2, plus 2. So it's basically x plus 2. But the next one, x plus 3. Why am I doing that? Because the difference between the x and the first term, only add 1. X and the second term, only add 2, because you have 2 jumps. X and the third term, only add 3, and so on. This is just a new idea for you guys, just to make sure that you have a good understanding of this. So to write consecutive numbers using variables, basically we need to understand the relationship between them and use one variable in terms of others. So I used one variable x for the first number, okay? And then I kept on using this variable for the other numbers, okay? They only want 3 consecutive numbers only, so no need for the fourth one. So they're saying that the sum of these 3 consecutive numbers is 132. So what does the sum means? Sum means if you add these 3 numbers, you should end up with a total of 132. I wrote my equation, walhamdulillah. Now I can think about how can I solve it. Yalla, bismillah. So, what do you think I should do first before I try to solve my equation? What do you think I should do first? Basically, looking at it, I can see clearly that I have the variable x written in multiple places, and I need to combine it because I'm used to working in linear equation. We have to combine the variables first. We have to have only one variable to isolate it. Okay, so yeah, now I have 1x plus 1x plus 1x. All together they will add up to 3x. Now what about the numbers? What do you think? Can I combine them? Of course I can. I can say also 1 plus 2 is also a positive 3. This is another way. I just only simplified my equation. So what happened here is I simplified my equation. Instead of having 3 x's written all over the place, I collect them in 3x. And instead of having 1 and 2 separated, I combine them into number 3. This makes my equation more visible and easier to work with. Okay. Now I can finally isolate my variable x. To isolate x, look at the term that is far away from x. It's positive 3. How can I cancel positive 3? Just minus 3 on both sides. Now what do I end up with? I have 3x equals 132 minus 3 is basically 129. Now, what should I do? The 3 is multiplied with x. I need to divide by 3 on both sides. So I can see that x equals 129 divided by 3 is basically 43. Okay. I found the first term, which is x. We agreed that the terms are what? X. The next one is x plus 1, because it's the same as the first, but add 1. The third one, we said it's x plus 2, because it's x plus 1 plus 2, okay? Since I found the first one as 43, plus 1, 44. 43 plus 2, 45. So these are the 3 consecutive numbers. I found them, alhamdulillah. طب do you want to double check if they will add up to 132? Let's double check here in the corner. So I want to add 43 plus 44 plus 45. These are my 3 consecutive numbers that I found. Let's add them up. I will just line them up over each other. It's going to be easier for me to work with. Okay, so 44 and then 45. Let's add them up. 3 plus 4 is 7. 7 plus 5, it's 12. 2 down, 1 up. 4, 3 times is 12 plus 1, it's gonna be 13. So yes, they are 132, and yes, my answer is correct. Okay, that's it for today, guys.